TEXPLORE, a reinforcement learning algorithm by Todd, Hester, and Peter Stone. This algorithm uses random forests of decision trees to model the transition and reward dynamics of a domain. Planning with respect to the aggregate model of the random forest enables the agent to balance exploring the models that are optimistic with respect to the true dynamics of the domain with those that are pessimistic with respect to the true dynamics of the domain. In this way, it can naturally balance exploration and exploitation. We will examine the agent in this domain called the fuel world domain. Here the agent has three state features: its row, its column, and a fuel level. The agent starts in one of the blue states on the left, and it can take one of 8 actions, indicated by the arrows in the center of the diagram. The agent's goal is to navigate to the goal state on the right. However, it does not have enough fuel to reach the goal state. Every step it takes reduces its fuel level by 1. The green states on the top and bottom of the domain are fuel stations. However, each of these stations has a varying cost, between -10 and -30 reward. Therefore, the agent needs to explore and find out what the best path is to the goal, incorporating the cheapest fuel station along the way. The idea behind this domain is that the white states are ones that are very easy to model and are not very interesting to explore. Meanwhile, the green states, because of their varying costs, are interesting to model, and some of them are very important for the final policy. However, some of the green states, for example the ones at the beginning or the ones past the goal, are not very useful and should not be explored. And also, some of the fuel stations, because of their high costs, perhaps are too expensive to explore, and at some point the agent may be better off settling on the policy it has rather than spending more and more costs trying out all the different fuel stations. So now let's take a look at how the agent operates the domain. We're leaving a trail behind of where the agent has been, so you can see where it's acting. So you'll see the first few episodes, the agent is wandering around somewhat randomly. It has to at least get some sense of what the different states and actions are. But pretty quickly here you see it going to the goal each time, just trying a different fuel station every time, both on the top and on the bottom. And in this case, the cheapest fuel stations were in the 10th column on both the top and bottom. The bottom one was slightly better if it started closer to the bottom of those blue cells. And so you'll see already just 30 episodes in, that 10th cell is very white because that's where the agent has already decided to keep going. And as you can see in this diagram, the agent hasn't explored some of the fuel stations, both at the end and at the beginning. It's really just exploring the ones in the middle that are useful on the path to the goal. So this experiment shows how the TEXPLORE exploration is able to balance exploration and exploitation and very quickly find good policies to solve the task.